Today we will learn how to perform exponential transformation in Matlab. In the last lecture, we performed logarithmic transformation in Matlab. Logarithmic transformation changes the darker part of an image, whereas exponential transformation changes the brighter part of an image. Let's implement the code first. After that, I will explain the theoretical concepts. First, load the image using imread function, then convert the image into double data type. It is required to convert the image, otherwise it will not work. The first base value is 1 plus 0.3. The second one is 1 plus 0.4. And the third one is 1 plus 0.6. Showing the image using subplot function. Run the program. Here is the output. The first image is the original image. The second, third, and fourth images are transformed image. You can see how the images have transformed based on different base values. The bright part has become brighter, whereas the change in the dark areas are negligible. So how does it work? The input image is the input to the exponential function here. Image ij represents a specific pixel value. That means we're working on pixel. As we're working on pixels, and pixels are discrete, we used element-wise operation in Matlab. You might have noticed that the equation we used in Matlab is little different than the direct exponential equation. Mathematically, this is the exponential equation. However, instead of using this, we use this equation. Instead of e, we used 1 plus alpha, and the value of alpha in our code is 0.3, 0.4, and 0.6. Here c is a scaling factor. It ensures that the output will lie in an appropriate range. However, if there is no input, that means I equals 0, the output will be c, the constant value, which is obviously unacceptable. We can't have any output when there is no input. That is why we have subtracted 1 and formed this equation. Now, if the input is 0, that means I input equals to 0, the output will be 0. This is how this equation represents the exponential transformation of input image. This is the diagram of our exponential function, and this is the result we found after performing exponential transformation. 0.3, 0.4, and 0.6 represents the value of alpha. Alpha equals to 0.3 produced this curve, alpha equals to 0.4 produced this one, and alpha equals to 0.6 produced this curve. the pixel value of this location is very small. That is why it is representing dark color. That means the values of these pixels fall in this region. For these inputs, the output doesn't change that much. But pixel values of this region is high. That is why the changes in the output is significant. These points are representing this region. This is how the exponential transformation works. I hope you have understood how to perform exponential image transformation in Matlab. Thank you for watching. Don't forget to subscribe.